Another example of finding prime factorization and prime factors, and I've given you another procedure that you can try if the numbers are quite big. And the one thing to try is if it ends in a 0, that tells you it's divisible by 10. If it ends in 2 zeros, it's divisible by 100, and 3 zeros, it's divisible by 1,000. If it ends in a 5, you can also assume that that's going to be divisible by 5 as well. So I'm going to begin with 50 and 40 at the top, and I'm going to break that into 2 branches. And because it has a 0 at the end, I'm going to immediately know that 10 will go into it, and it's going to be 10 times whatever those first 3 numbers are, which is 154. Now neither of these are prime, but it's fairly easy to break 10 down into 2 and 5, which are both prime numbers, so that's done. And 154 is going to get broken into 2 and 77, and the 2 is done. 77 is 7 times 11. And so again, the prime factorization in this case is equal to 2, and let's do it in order, times 2 together, times 5 times 7 times 11. You're going to find that some teachers and some textbooks like it to be written smallest to largest. And what are the prime factors? The prime factors are just a list of all the numbers that you see here, not using duplicates. So there's a 2, there's a 5, there's a 7, and there's an 11. The next thing we're asked to find is what's called the greatest common factor. And the greatest common factor is when you're given 2 or more numbers, the largest number, prime or composite, that will divide into all of the given numbers. And for short, we're going to call it GCF. So for example, the greatest common factor between 12 and 18 is 6, because 6 is the largest number or the biggest number that will divide into both 12 and 18. So again, I have some steps here that will help you find the GCF. And like most things today, it involves using the factor tree for these numbers here. So the first step is to find the prime factorization for both. Now to find the prime factorization, you go back to your previous step and you realize that that means you have to do a factor tree first. So a factor tree for 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. And then let's look at 60. 60 is 2 times 30. 30 is 2 times 15. And 15 is 3 and 5. And keeping short this time, I'm just going to call it PF for prime factorization of 24 is equal to 2 times 2 times 2 times 3. And the prime factorization for 60 is equal to 2 times 2 times 3 times 5. Now, we are actually going to create a new list. And this new list finds all the numbers in common between these ones. And you can have repeats in this as well. So let's underline what's in common. This has a 2, this has a 2. This has a 2, this has a 2, this has a 3, this has a 3. So our GCF has in it a 2 times a 2 times a 2, oh no, a 2 times a 2 times a 3. And then we're actually going to take and we're going to multiply those back together. 2 times 2 is 4, times 3 is 12. And that is the GCF of that particular question.